A, it's got to be the first circled one in your priority list. So we schedule A, and that takes 5 minutes. Processor 2 also needs something to work on. So what's my next ready one? C. And that takes 6 minutes. Okay. All processors are busy at this point. So they're working. Processor 1 stops here at 5. What task are they finished with? A. Okay, that leads into F. So F is now ready. So I circle it in my list. Okay, I have 2 ready tasks, but only 1 open processor. Which one should be scheduled next? B. So we're at 5, adding 7, we're going to 12. At 6 minutes, we stop again because processor 2 has finished with task C. Does that mean D is ready now?
No.
No. There's another line that leads to D that's not done yet. So the only one that is ready is task F, so that goes next. That takes me to 9. Okay. So at 7, they're working. 8, they're working. 9. We're done with F. F leads into E, so E is now ready. That's your next ready task, so we schedule E. That takes me to 18. Okay. So E is now scheduled. We're working at 10, 11, 12, we stop. 12, task B is finished, which means D is finally ready, which means D gets scheduled here, and they're done at 15. All of my tasks have been scheduled, so my finishing time is 18 minutes, and processor 1 is going to idle for the last 3. If you didn't get this, do you understand and see where you went wrong? All angry back there, like a bear, growling at me.
I'm growling at you. My stomach's back here growling. I ain't hear no crack.
Your stomach's growling? Okay. What tasks are ready from the start in this one? E and D. E and D. What gets scheduled first? E gets scheduled first. That takes me to 6. D gets scheduled second. That takes me to 4. So both processors are working until I get to 4. Now I'm done with D. D leads into A and into F. What is ready now? A. Again, F is not ready because D and E both lead into it. So A can be scheduled next. That takes me to 9. At 6, we finished with E. E leads into F and B. What's ready now? F. Anything else? B. Just because you're not going to schedule them both doesn't mean you shouldn't circle them. Please circle them as soon as they're ready. So now, the first ready task is F. That goes here, and that finishes at 9. At 9, we finished with F and A, which means C is now ready. Okay. So I've got 2 open processors and 2 tasks. We can schedule them both. B gets scheduled. That takes me to 17. C gets scheduled. That takes me to 11. All of my tasks have been scheduled, so we finish at 17, and this should be idle time. Anybody questions, issues, problems with that one? Okay. We technically have 3 sections left to cover. This next one's literally a page. If you got this and you're good, even if you're okay, you should be golden the rest of this chapter. Okay. So, okay. Please remember, your priority list does not mean and has nothing to do with prerequisites. So this first blank up here is nothing. Just because I tell you A should come before B does not mean that in the graph it's going to show A coming before B. Okay? So please remember that. So they decided you coming up with a priority list still doesn't give us an optimal time. So we're going to try something new. And the something new is called the decreasing time algorithm. What does it mean, decreasing time? What should I start with and what should I go to if I'm decreasing? Highest to lowest. So guess what? We're going to create a priority list that goes from your highest time to your lowest time. So instead of them giving you a list this time, you're going to actually come up with it yourself. So that's the first thing we have to do is come up with your decreasing time priority list. What's your biggest number in your graph? 7. So C. What should come next? Decreasing time. A. Then what? B and E. It doesn't matter if you write B and then E or E and then A or B. Okay? It does not matter what order they come in because they have the same time. And finally, we want to try to finish with D. So that's the only thing that's changed from what we did on Friday. Instead of me giving you a list, you have to create it. Everything else is the same. What tasks can be done from the start?
A and C.
A, B, C. Okay, all of your tasks that are ready from the start, A, B, and C. So, what should be scheduled first? C, that's 7, and then A, that's 6. You have 2 processors, you had to pick 2 tasks. So, as I work across, at 6, I stop. And A is finished. Is anything else ready once A has finished?
No.
No. E is still not ready. D is still not ready. Okay? But I already have one that's ready, so we can go ahead and schedule B. B takes 5 minutes. That takes me to 11. Yes, it is. I promise you. Okay? So we've scheduled B. At 7, we've now finished task C. C leads into E. So E is now ready. We can go ahead and schedule E. That takes 5 minutes. So that takes me to 12. At 11 minutes, we've finished with task B, and that led into D. So now D is ready. And D only takes 2 minutes, which takes me to 13. All of my tasks have been scheduled. This last hour for processor 1 is idle time, and we finish at 13 minutes.
What?
Please understand, I will never give you a timeline that is shorter than what you need. It may be a little longer, but it will never be shorter than what you need. So if for some reason you're going over your timeline, you did something wrong. Double check it. Questions? Okay. Example number 2. Again, priority list first, decreasing time. What task should we try to do first according to this priority list? E. Then
B.
B,
C.
C,
A.
A, F, and D. Okay, according to my graph, What letters in my priority list are ready?
A, B, C.
A, B, and C. So, according to my priority list, processor 1 should be scheduled B, which takes 7. Processor 2 should be scheduled
C.
which takes 6. Okay, we don't stop until we hit 6. At 6, we're done with task C. C led into D. Is D ready yet?
No.
No. Do I have anything ready that I can schedule?
A.
A. We add 5 to 6, which takes us, whoops, I went one over too far. Yes. I just looked at the blocks and wasn't paying attention to the fact that I was between 12 and 14 instead of 10 and 12. Okay. We have another pit stop at 7. 7. I'm now done with B. B leads into D. Is D ready now?
Yes.
Yes. Okay, so we circle it and we schedule it. And that'll take me to 10. We're busy at 8. We're busy at 9. We don't stop again until 10. At 10 minutes, processor 1 is done with D. Michael just said, oh, I can't do nothing. So if we can do nothing because nothing is ready, that means we idle until the next task is done. You look at your list and nothing is ready to go, we have to idle until the next task is over. So at 11, we finally finished with A, which means what is ready?
F.
F. Okay, I've got 2 processors open and only 1 task. You can assign it to either processor. Where would you like it to go?
Second one.
The second one? Okay, so that means the second one's going to work till 14. Well, if processor 1 has nothing to do, they're going to idle. Clear till F is done. At 14 minutes, we finished with F, which means E is now ready. Where would you like to put E? 2 again. Well, you're going to make processor 1 lazy. 2, 4, 6, 8, 23. Which means processor 1 has nothing to do again. And my finishing time then is 23 minutes or 23 hours or whatever.
23 years.
Oh, God.
Yeah.
That's a long time to be working some stuff.
Nope.
Doesn't even take 23 years.
Doesn't take that long.
How much you want, 20 stories? 57 bedrooms?
Living by yourself, that's not crazy.
The White House.
My dad and I rebuilt my house in Pennsylvania in a couple of months. And that was just my dad and a couple of friends and me.
The White House.
Do you know how many people work on that, though? It's not like it's 2 people that work on the White House.
You know, two people might take 23 years.
Right. But they're going to have a big, huge crew working on that.
Right.
Okay. Example 3. Decreasing time priority list. What should we try to do first?
Or the highest.
Which is
B.
B, followed by E, A, D, F, and C. Okay. According to my table, though, what can only be done from the start? Okay. D and E are the only 2 available from the start. According to my priority list, what should be scheduled first? E for 6 and D for 4. So we're working until 4. At 4, we've now finished with D, which leads into A and F. What is ready now?
A.
A is now ready. Why is F not ready yet?
Because it needs to be done.
Good. Okay, there is another prerequisite. Okay, please do not lose that prerequisite. So A is the only one ready now. So we schedule A after this. That takes 5 on top of 4, so we're at 9. We're working at 5, we stop at 6. At 6, E is now finished, which leads into F and B.
We gotta do B first.
Okay? Don't worry about what we're doing first. What is ready now?
B.
B
F.
and F. Okay? Take it one step at a time because if you don't, you're gonna mess it up. So, yes, now that we have these two tasks circled, B comes first. So B gets scheduled first, which takes me to 14. At 9, A is finished. Is C ready yet?
No.
No, but I still have F that's ready and can be done. So we schedule F. That stopped at 9. We're going to finish at 12. At 12, F is now finished, which leads into C. Is C ready now?
Yes.
Yes, so it's ready, and we're going to go ahead and schedule it, and that takes me to 14. There is no idle time. No idle time on this one.
What?
Questions on decreasing time?
No.
Okay. This is it.
That's it for today.
All right.
Oh.
Okay, so the last thing we need to talk about is critical paths and critical times. So, and I'm telling you now, there's one on the release test on critical times. So I guarantee you're going to see this again.
Hold on. My pages are all out of whack. So hold on.
Your pages are out of whack.
Yeah.
It's Friday, be the last day, so. Oh, it's January. What's the final exam? Where is it? What's your notes?
I'm just going to stick with this a little bit together. Because you should have the rest of the notes in your packet. You really have to do this part of it.
Yeah, you're right. So, I mean, you can put it back over there. Yes. All right.
Yeah.
Okay, wow, wow.
Right.
All right, so we have been looking for the optimal scheduling time. The way we do that with critical path, though, okay, so we're looking for the path from some point X to the end with the longest total processing time. They say if we go from the longest critical time to the shortest critical time, that will give us an optimal schedule. So the critical path is the longest path from that point to the end. The time that goes with it, the time that goes with it is the total processing time of all tasks along the path. So what they mean by that is if I start at HU, okay, Vertex 1, this tells me to start at HU. Let me drag this down. So, if I start at HU, how can I travel from HU to get to the end? I can go HU to where?
PD.
To where?
PD.
PD.
I see.
Can I go from PD to IC? No. So, one path. PD to the end. And that gives me
7.
a critical time of 7. HU had 4, PD had 3, and the end has nothing.
Oh.
What's another way I can go from HU?
Oh. I see.
HU to IC to FW
That's your critical.
to the end. Okay, so HU was 4, plus 1 is 5, plus 6 is 11. Give me another way I can go from HU to the end. HU to EU to the end.
What?
If I add up the numbers from HU to EU to the end, I get a total of 6. So your critical path would be that middle one.
Yeah.
From HU to IC to FW to the end. It's the longest. Your critical path always is the longest way from beginning to end. Okay? So, number 2 wants us to start way back here at AD.
Right.
Victoria just said you can only go one way, and then Alexa said it, and Trey agreed. Okay? The arrows only point in one direction, so I have to go from AD to ID to PU to EU to the end. Yes, EU. Okay? So, that's 8, 5, 3, and 2.
18.
That's a total of 18. And guess what? That's got to be the critical path because it's the only way to go. Okay? Got it. Number 3 wants us to start at IW. Okay, you said IW to where? IP. IP to where? HU. PD. To the end. So that's 7, 4, 4, and 3. That's 14, 18. 18 for that one.
Do I really have to write end at the end of all of them?
I put
Say,
I mean, isn't it
Yes, sir.
implied that
And jelly. What?
You can't just end at PD.
It can't just end at PD if you don't put in, then
Right, gotta go to the end.
right, got to.
Right.
Technically, it's wrong if you don't write.
That's how you serious.
I understand where you're going with it, but technically, it's wrong if you don't write it.
But I see what you're saying, though. It is stupid, though. Like,
I get it. Another way I can go.
IW, ID,
ID,
PU.
PU, EU, N. So that's 7 and 5, which is 12, 15, 17 for that one.
17.
Okay, 17 for that one. Then
Right, go to IPHU,
I
ICFW.
hold on. You said IW to where?
Yeah, IP,
IP,
HU,
HU,
IC,
IC,
FW,
FW,
N.
N.
I remember back when I was a kid, it used to be like, spell
So that's 7.
yeah.
13, 18, 22. Okay, I think you guys have gotten the point. Okay, I do believe that one's actually your critical one.
Now it's like 3 more. It's 1.
there is like,
There's 2 more.
Right.
Okay, this one actually is your critical one, but technically there's 2 more. Okay, if you had to sit here and guess, what is the and guess
Two
them.
more.
Honestly.
Okay.
Kind of like
Just give
The
the
shortcut.
shortcut grip.
So
2, 3. I kind of 3.
we have a shortcut. And your shortcut,
So we don't have no
we're going to use the backflow algorithm to do the shortcut.
Okay, hold on.
So,
It's on the same page.
yeah, it's right there.
Oh.
I got you. Okay, so we're going to use something called the backflow algorithm. So we're going to start at the end and we're going to work our way backwards, finding the longest time working backwards. Be careful. Instead of having, you're going to have parentheses, which tells you how long it takes to do the task. But now we're going to add in numbers in square brackets. The numbers that go in the brackets are the critical times. That tells you how long it will take you from that point to the end. Okay, so what I mean by that, if you look at this. So if I have to work backwards, and I've got 3 lines leading into a point, I can either go from A backwards, B backwards, or C backwards.
B, right?
You always want to go from your largest time. So yes, I'm going to go from B backwards into X. Well, how do you get the critical time for X? You take the critical time for B, which is 15, and you add the critical time for X, which in this example is P.
So it's 15p.
So it's 15 plus P. Don't write 15P because that means 15
Multiply,
times.
yeah.
So that's
Okay.
it.
So your critical time for vertex X would be 15 plus P. Okay, so we're going to do that with all of your graphs. Hold up. Hold up.
It'll be easier when we do it.
Okay, so here's example 1. Okay, from the end, I can go to F, I can go to G, and I can go to H.
We should go to F.
So I have to go to each point. Every point has to have a critical time. So if I go from end to F, that's 0 plus 6, which gives F a critical time of 6. We said I can also go from end to G. 0 and 3 gives G a critical time of
3.
3. You also said I can go from end to H. 0 and 2 gives H a critical time of 2. Okay. Now, F leads backwards into C. Well, I started at 6. I'm working backwards.
11.
11. G goes backwards into D.
13.
Three.
I'm still on C.
Boy, you slow.
Seven.
Never that.
Oh, nah. 3 plus 4 is 7.
So is B gonna have 2?
Hold on. We're going to talk about that in 1 minute. Okay. So we went from G, which started at 3, backwards to D, which had 4, which takes us to 7. H. H goes backwards into E. H started at 2. 7 gives me 9. Okay. Now, Marcus said, does that mean I can stop and you can watch the recording from last semester if that's what you want to do? Marcus said B has 2 lines going backwards to it. Remember though, critical path means the longest. So am I going to go backwards from 11 or from 7?
11.
I'm going from 11, which gives me 13.
So that means D just stop right there.
Okay. D just stops right there. Okay. E goes backwards into A. Well, E left us off at 9.
10.
This gives me 10. And then they all have to go backwards to the start. So would I take B backwards to the start or A backwards to the start?
Because it has the most.
I'm going to take B backwards, which means my starting time is 13.
I like this easier than the.
So if they say find the critical time for each vertex, that's what's in the brackets. You already did that. You did part. Part B says find the critical path for the given project. So the critical path goes from start to end. What's my longest path going from start to end?
DCF.
BCF, end.
So like A would be 13 and B would be BCF. And like,
How would A be 13?
find the perfect time. Oh, for each number.
A is just all.
And I'm sure ain't nothing funny.
If they asked you what the critical time was for your path,
Yeah.
yes, it would be 13.
Tonight.
Okay. Let's try this one. Okay, again, you always work backwards from the end. The end goes to D. That means D has a critical time of
2.
2.
Then it go to
End also goes to E.
5.
So critical time of 5. Okay. From D, there's only one way to get to A. So we were at 2 at D. We go
8.
backwards to 6. That's
8.
8. Okay. From D, we can also go to B. 7. And from E, I can go to C.
12.
Gives me 12. Okay. Now, I've got 3 lines that branch backwards into start. Which way am I taking? C. Back to start. So that's 12. So, again, you just did A. Find the critical time of each vertex. B says find the critical path. So, which way do I go? Start to C, to the E, to the end.
And then what we have to do-
And it asks for the time, so you would tell me 12. Okay, it says the path and the time it takes. So you would give me 12. Find the critical path for task A. So this just means I start at A and I go to the end. ADN.
Oh,
Part D says find the critical path starting at C. CE end. It's everything but the start. And finally, E says find the critical path starting at D. D end.
Miss Smith, if I gave you $1,000, would you sing for the
If you gave me $1,000, would I sing for the class?
Yeah.
Like I don't do any of that on a regular basis.
I'm talking like for real though.
Say what?
Okay, if we have time, we're gonna go back and do the critical times for this one. You're never gonna have anything this ugly. Okay, so I'm not gonna spend my time working on that. We're gonna finish up the rest of it. So we'll skip that for now. Thank God.
I don't feel like doing that whole big example either.
I don't feel like doing that whole big example either. What's the matter?
We done.
251.
Okay, so why are these paths and times significant? Well, a critical path is a specific order that task must be completed in. Okay. The beautiful thing about your critical path is any task in the path. Any task in the path cannot be started until the previous task is done. basically what you've done is you've created a list of your tasks that go in order according to your graph when you create a critical path. So it takes into account the prerequisites that have to happen before the others. Okay. Your critical time is the minimum finishing time that the project can be completed in. Your finishing time can never be smaller it can never ever be smaller than your critical time. I believe we have 4 more examples.
One,
And chapter 8 is over.
2,
Boom.
no, it ain't. 34. Oh, yeah, it is, girl.
Yeah, it is, boy.
Wait, I thought we was testing. Oh,
Wednesday.
Tomorrow.
Tomorrow's review day. So tomorrow you guys are gonna come in. I'm gonna let you work on like problems 1 and 2. We're gonna go over them. Then you're gonna work on 3 and 4. We're gonna go over them. Okay. All right. So the last thing we need to create is what we call the critical path algorithm. Just like you did with decreasing, where you took them and put them in order from greatest to least of your processing time, we're going to do the same thing. But instead of using the processing time to create your list, we're going to use the critical times to create your list. So on your test, you're going to have to go back and you're going to have to give me all of these bracketed numbers. Okay? Then you're going to have to create your priority list according to these numbers. What is your highest critical time?
B or 12.
B, 12. Okay? So we're going to try to do this with B first. What should come second?
C.
No,
C.
C,
A.
A,
E.
E, D,
F.
F.
No. What number are we looking
G.
You're
G,
looking
no,
at the
brackets.
critical time. The
Oh,
ones
the one
in
in
brackets.
at? Okay.
Okay.
G.
So G and then H. That's where most of you are going to get messed up on your test. Instead of looking at the critical times, you're going to look at the processing times. You're going to create the wrong list. Okay. So please be careful. Your priority list, when it says critical, you're looking at the ones in brackets. So now, what task can be done from the start? B and A. Everything goes back to what you already know. B and A. I've got 2 processors, so one's going to take task B. Now be careful. When you schedule, you're not using your critical times. You're using your processing times. So B only takes an hour. A only takes an hour. So when you're putting them into the schedule, you're looking at the numbers in parentheses. Again, if I give you a list of 20 and you've got to put something in there that takes 12 hours, that's going to take up most of your list. It doesn't make any sense. Okay, so try to think logically about it when you get it. Okay, at 1 minute, we've now finished this task and this task. B leads into C and D. A leads into E. So what is ready now?
C.
C and E.
C and E and D. Woo! I've got 3 tasks ready now, but only 2 processors. What am I scheduling?
C.
C and E. C goes for 5, which takes me to 6. And E goes for 7, which takes me to 8. Okay, we're working. Stop.
D goes for processing.
C is now finished. C leads into F. F is now ready, so we circle it. Even though I have 2 tasks ready, I only have 1 processor open. So which task does that processor get?
D.
D. That takes 4, so that takes me to 10. At 8, we've now finished E. E leads to H. So H is now ready. What task gets scheduled now? F. That takes me 6, so that takes me to 14. Whoop, I didn't mean to cross that out. Okay, at 10, we've now finished with D, which means G is now ready. So, which task gets scheduled?
G.
G goes first. Remember, it's got to be in the order of your list, if you can. So G goes next. At 13, G is finished, which means H can then come after that. So my total time then is 15, and processor 2 will have an hour of idle time. Questions? Okay, these last ones, these are the ones we're going to have to go back. We're going to do all the critical times first, create our list, and then schedule. Okay, this one doesn't give you the critical times. So we're going to go back and practice that some. So if I go from the N goes to F. 5. The end also goes to G. 4. Okay, there's only one way to go backwards to C. It goes from F, so we're getting 8. I have 2 lines that go backwards into D. Okay, we're going to take F back into D. If I took G, that would only be 4 backwards. F is 5 backwards. So that gives D 11. G goes backwards into E, which gives me 11 here as well. Take a look at B. I've got 3 options backing up into B. Okay, I could use E or D, doesn't matter. Jeremiah said E, so let's use E. So E started at 11, that makes B 13. E also goes backwards into A, started at 11, adds 8, 19. And which one are we taking back to the start? A.
Yeah.
All right. So now that you've got your critical times, we have to come up with your priority list.
A, B, D, E.
A first. That's my biggest one, 19.
D.
B comes second.
D, D.
E or D, it doesn't matter which order you put them in. Again, they have the same critical time. Then C,
F, G.
F, and G. Okay, which task can be done from the start? A and B.
Pardon the interruption. Please dismiss the members of the men's tennis team at this time. Members of the men's tennis team. Thank you.
Spades.
A and B can be done from the start. I have 2 processors open, so we're going to schedule both. A takes 8 minutes. B takes 2. I'm done here. So B is now finished. B leads into C, D, and E. So, is C ready yet?
Yeah.
Yes, circle it. It also led into D. Is D ready now? Yes. Circle it. It led into E. Is E ready now?
No.
No. A has not led into E yet. So the only two tasks that we've added to our ready list are D and C. What comes first? D. That takes me out to 8. At 8, both processors are done. So A is done, which led into E, which makes E now ready. And we've also finished with D. D led into F. Is F ready? No. D also leads into G. Is G ready?
No.
No.
Why is F not?
C leads into F. Okay. Good question. So my only two ready ones are E and C now. I have both processors open. So again, I can schedule both tasks. E is 7, so that takes me to 15. And C is 3, which takes me to 11. Okay. C is my next one that finishes at 11 minutes. C leads into F. Is F ready now? Yes. So we circle it. It's the only one ready, so we go ahead and schedule it. F takes 5 minutes, which takes me to 16. At 15 minutes, we've now finished task E, which leads into G. Is G ready now?
Yes.
Yes. So G can be scheduled, and that's left me off at 15, so that takes me to 19. Have I scheduled everything?
Yes.
Yes. Drop your line, and this last little bit is idle time, and we finish at 19.
Hold on, man.
Questions? This is it, though. What? We got 2 more. What, you don't want to do them?
It's on me.
I said there was 4 more to go. We've done 2.
I know we don't got no homework.
Oh, I know you do.
Yeah.
Homework
Oh,
is
and the
quiz.
quiz.
We had to take home quiz.
But that is it. That is your
It's just
homework.
a quiz.
Might as well have to take home test too.
Now,
Take home test.
listen,
Take home fun.
you don't want to do these last 2. We don't have to.
Might as
We
well.
need to do them.
Right.
Let's just do one.
You was, you ain't even come to school
Sleep.
today. Your day don't even count. You absent in state book. I ain't even here today.
End to C gives me a critical time of 4. N to I gives me a critical time of 3. Okay, what goes backwards into B? C, which means B has a critical time of 6. What goes backwards into F? I, which means F has a critical time of? What goes backwards into H? Which means H has a critical time of? Okay, which way am I going to go backwards into E? F. Okay, I could either take 6 or 8. We're going to take the 8, which gives E 11. How do I get backwards into A? B, which gives A 11. How am I going backwards into D? E. It wouldn't have mattered if you took E or H. It still gives D 17. And if you go backwards from H to G, we're at 18. So what's my critical time? Where am I going to get started? 18. Okay, so you said it's G, D, A, E, H. Okay, those can be interchanged. F, B, C, and I. Look though, I now have 3 people working.
Easy.
which makes it a little bit easier. Okay, what's ready from the start?
GADG.
A, D, G. Did you notice
Yeah, 3.
that the ones that you circle are at the beginning of your priority list now? Okay, that's what makes it a little easier to schedule. I've got 3 ready and 3 open processors. So G's gonna go first with 7, D's gonna go second with 6, and A's gonna go last with 5. Processor 3 finishes first with task A. A leads into B. Is B ready though?
No.
No. Hey, do I have anything ready?
Hey,
Okay, this is where it gets difficult. So, pay attention. There's nothing ready. So this person has to idle. Are you not?
wait, who got idle?
Okay, they're gonna idle until that next task is ready. Task D doesn't finish until 6. Okay, so now D is done, which leads into E and leads into H. Is E ready?
Yeah.
Yes. Is H ready?
No.
No. Okay, so now I've got 2 processors open, 2 and 3. Only 1 task available.
Go to 3.
Do you want it to go to 2 or 3?
3.
3? Okay, let's do down here. So E takes 3 minutes. That takes me out to 9. Processor 2 has nothing to work on. So they're going to idle now until the next one's done. Well, my next line comes at 7. So they're going to idle until 7. At 7, we're now done with G. So now H is ready. But we're in that same situation where I have 2 processors open and only 1 task. Where are we putting it? 1 or 2? 2. H goes here. And that's 8 on top of 7. Takes me to 15. Again, processor 1 has that issue. They can't do anything until 9 minutes. So they're going to idle until 9. At 9, we're now done with E. And E leads to F and to B. Is F done and ready to go?
Yes.
Yes, F is ready. Is B ready now? Yes. So now I've got 2 processors, 2 tasks. So one gets F, which takes 5, takes me to 14, and one that takes B, and that's 2, which takes me to 11. I stop here at 11. So B is done. B leads into C. Is C ready though?
Yeah.
Yes. Okay, so now we schedule C. And that takes me, we're at 11, takes me to 15. Okay. At 14, we're now done with F. F leads to I. Is I ready?
No.
No, I's not ready until H is done. Well, H isn't done until 15, so we're going to idle till 15. At 15, H is done, and that leads to I. I is now ready. I've got 3 processors open and 1 task to do. You want to give them to 1. Okay? So I goes here. We had 15. That takes me to 18, which means these other 2 idle until I is finished. We have a finishing time of
Right.
okay. It is super confusing when you start adding in all this idle time here, there, and everywhere.
You like that though, easy to be honest.
Huh?
It was easy.
Really?
Yeah. I don't think I'll do, bro. Idle, bro. That shit just.
You want the last one? Or are we done?
Oh, no, we done.
Now we want to do that quiz.
done, you wanna do that quiz?
Yeah, that, I'm gonna do this tonight.